Hi, my name is Tamar, and today I'm going to be talking about writing blockchain clients in Swift. I'm going to be talking about the state of writing iOS apps on top of the blockchain, specifically focusing on the Ethereum blockchain. Today, there's no Swift framework to interact with the Ethereum blockchain. There's therefore a huge opportunity to contribute to the blockchain ecosystem and make it very easy to integrate blockchains on iOS. I'm so excited to be back in Japan. Watashi no nikunemu tamago. My name is Tamar, but when I travel, I like to take on different nicknames. In Australia, my nickname was Tim Tam, and I decided my nickname in Japan will be Tamago, egg. And this is a very famous egg. I look for technologies that are provocative and have transformative potential. Blockchain, decentralized ledgers more broadly, have the potential to transform society in meaningful, positive ways. Or maybe they won't. It depends who's involved. I wanted to give this talk today because I want you all to be more involved. I want the iOS community to be more involved, and I want our tooling to be on the level of JavaScript tooling, and Java tooling, and Go tooling, and Rust tooling. Today I'm going to be talking about a very specific aspect of blockchain development. Where Swift can currently be used in blockchain-based apps, and where I'd like to see it go. I actually passed by Luke's Lobsters in Shibuya the other day, and I saw this shirt, Luke's Lobster, no middlemen, just lobster men. That's kind of what blockchain development is all about. In addition to being immutable and decentralized, blockchains are changed and regulated by what's called distributed consensus. What's different about distributed consensus is that rather than having a middleman, some company or entity or institution deciding what changes get added to the blockchain, these changes are determined by a consensus mechanism. And I'll go more into that later. So again, today I'm going to be talking about Ethereum, and I thought I'd start by explaining what Ethereum is. And just one note of background. So I have a background in iOS engineering, and I'm new to the blockchain development world. And so this talk is basically trying to bridge the two communities. And if you're an expert in this space, I would love to learn more from you. So I thought I would explain Ethereum by talking about some app stores that you've probably heard of, and then comparing them to Ethereum, the Ethereum ecosystem. So we have the iOS App Store. I'm sure you all have heard of it. The iOS App Store is managed by Apple, and the purpose of the iOS App Store is to improve the experience of using iOS devices through third-party software. Facebook Messenger, so the motivation of the iOS App Store is selling phones or selling Apple hardware. Facebook Messenger App Store enables businesses to build experiences on top of Facebook Messenger, and the motivation for that app store or ecosystem is making the experience of businesses that use Facebook more valuable, and making the experience of users also more valuable, and of course, collecting data and showing ads. There's also an app store for Amazon Alexas. So these are similar in a way to the iOS App Store because Amazon develops this app store in order to sell Amazon Alexa hardware. And they want to improve the hardware experience through third-party software. And finally, Ethereum. So why is Ethereum on this list? What the Ethereum ecosystem does is enable blockchain-based products. So there's a cryptocurrency in the Ethereum ecosystem called Ether, but it's not purely a financial platform for developing financial products. The cryptocurrency there is used to drive the way that the platform works, but this can be the backbone for a lot of different types of products. Anything from financial software to a decentralized alternative to GPS. Any blockchain-based product or solution might be built on top of the Ethereum blockchain. So how do people write iOS apps that support Ethereum today? Well, you either need to use ObjectiveC or JavaScript. And when I say you need to use ObjectiveC, what I mean is that you need to use one of the frameworks that's written not in Objective-C, but that can produce Objective-C code. And I'll talk more about that in detail later. Today, there's no Swift Ethereum client. So in a way, the title of this talk is a little bit deceptive. We have ways where we can interact with the Ethereum blockchain from Swift, but the actual client is not written in Swift. There's a huge opportunity to dramatically change how iOS developers write Ethereum apps, and in general, how much the blockchain development space grows. You could think of this as the Alamo fire of iOS Ethereum development, or the Cocoa Pods of iOS Ethereum development. Community-developed tools that dramatically transformed the space. The framework that we don't have yet is on this same level. Whoever works on it, the community that works on it, is going to make a huge impact. So let's get to the meat. How does an iOS app built on top of the Ethereum blockchain work? So this is kind of like the basic architecture. And I'm going to be talking about Ethereum specifically, and there might be other architectures that people are using, but I'm talking about the sort of major architectures and tools that are being developed today. So the iOS client, let's start with the part that we love, the iOS client. So the iOS client requests data, requests transactions, new transactions to happen, and interprets responses in the UI. This is the same as any other iOS app that you've already probably worked on. Then we have a layer that we could refer to as the Ethereum client. And that's basically what directly interfaces with an Ethereum node. And the Ethereum node is what contains the blockchain data. And so generally speaking, what the Ethereum client is responsible for is telling the Ethereum node to do things, to provide certain pieces of data, or to add new to attempt to add new transactions. The middle layer, that's what we don't have written in Swift today. And we have alternatives that are written in Java and JavaScript and Go and other languages as well. And finally, the data layer is the Ethereum node. So this is a representation of two types of architecture here, and I thought this would be interesting to talk about in a room of iOS developers. So you basically have two options. The Ethereum data and the Ethereum node can run on the mobile device, or it could run on a different piece of hardware. So on the left, you see all these colors that represents the blockchain data and the Ethereum node. And on the left, if I'm requesting data, it would actually be contained in the app itself. Whereas on the right, if I'm requesting data, I'm requesting it from somewhere else. And there are different ways this could be done. You could use a middleman third-party service that runs a node, or you could actually have something developed in-house at your company. Ultimately, the right architecture would be considered less decentralized because you might actually have a piece of hardware that's a node for a lot of different clients. And it's just a trade-off whether you want to architect it like that or the style on the left. The other thing that's important to note here is that you can actually run a different type of node depending on what your goals are. So on mobile, you can run what's called a light node. So a light node is basically a node that contains a subset of blockchain data. More specifically, it contains the block headers. And they're much smaller than just the full blockchain. And that is super important when writing iOS apps on top of the blockchain. Let's zoom in on the blockchain itself. So I'm not going to talk in detail about how blockchains work, but I just wanted to focus on this because it's super cool and interesting, and it's relevant to mobile development. So what you're looking at here is a tree whose root is part of the block header. And if you look at the root of the tree, it has a lot of different colors. And you might notice that all the colors in the root are the colors of the children in this tree. That's because this data structure is called a Merkle tree. In Ethereum, they use what's called a Patricia Merkle tree. The Merkle root is the colorful rectangle. And you might notice that if I want to find out which colors or hashes are in the root, in the entire tree, I can just look at the root. And that's exactly what you do on the Ethereum blockchain. So it is a really smart data structure for this particular technology because it enables reducing the amount of data that's needed to, for example, run a light node. And you use what's called a Merkle proof to determine which hashes make up the root. So just to reiterate, the root is the hash of all of its children, and you can actually just look at the root to understand which transactions are part of the tree. And that's really useful for something like, let's say a user requests a transaction. How are we going to efficiently show whether the transaction went through? We can look at the root, see if it's in the tree, and if it is, we can send a happy message back to the user. One of the Ethereum creators actually has credited this data structure as the thing that enables mobile apps that support the Ethereum blockchain. He says, thanks to Merkle trees, it is possible to build Ethereum nodes that run on all computers and laptops, large and small, smartphones, and even Internet of Things devices. The last thing that I want to say about Ethereum is to mention smart contracts. So smart contracts are an important part of the space, and what you really need to know is that smart contracts have to compile to Ethereum virtual machine bytecode, and they can't be changed once they're compiled and added to the blockchain. But what's useful about them is that you can access them at a certain address on the blockchain and reuse them when a user, for example, requests the same kind of transaction to happen twice. You can access that contract and reuse it with different inputs. So what about Swift? Now I'm going to talk about, if you want to write Swift on the Ethereum blockchain, how you might do it today. So if you want to integrate the Ethereum blockchain into your iOS Swift app today, you have to, like I said, either interact with ObjectiveC or interact with JavaScript. Let's start with ObjectiveC. So there are a couple frameworks that are not written in ObjectiveC, but that can be used, that can generate ObjectiveC runtime bindings. And these include Geth, Parity, and Web3 which is the Java framework. This is an example of how this looks. We're trying to get the account balance, and this is the method that we would call on the Geth Ethereum client to do so. Another option is a framework or a series of frameworks called Web3 a series of modules. And this is how Web3.js looks, written in JavaScript. And these provide the core functionalities that you need to interact with the Ethereum blockchain. So just to highlight a few, we have a module that lets us interact with accounts, a module that helps us interact with contracts, etc. So how would you actually use Web3.js from an iOS app? There are two options that I'm seeing people use. One is to use it from React Native. And so you already have a React Native app, or it's a priority for you to add Ethereum support on an iOS app, and you might add React Native to your app in order to integrate Web3.js. And React Native runs natively on the JavaScript runtime. Then you can alternatively use Web3.js from WebKit. So WebKit is basically a framework that lets you develop basically web views on iOS. And in this architecture, Web3.js is basically integrated the same way that it would be integrated on a website. So what are the challenges here? I thought I would talk about types of challenges and then describe which of these techniques are subject to those challenges and problems. So probably the biggest one is language. So, these Go and Rust frameworks and JavaScript and Java, we're developers, we can learn new programming languages, but it's challenging to do so. And if you wanted to make it easy to add Ethereum support on an iOS app, forcing an entire team to learn a new programming language is not the easiest way to do it, right? And if you think about it, it's not, can I read a line of Java? Usually what you're not able to read from ObjectiveC is the implementations of different functions, right? And so you would have to go into a different code base, read the Go implementation or Rust implementation, and then you would also have to understand how GoBind or the other tool that's producing ObjectiveC, how it's becoming ObjectiveC code. So it adds a lot of complexity, which is a big problem for cryptocurrency, security is super important, and you want to have very deterministic code. You want to know exactly what your code is doing, and if you can't even read it, it's much more challenging. Performance is an issue. Performance in WebKit is probably a significant issue. If you're using WebKit, why not just use a mobile optimized website, unless you want to be part of the App Store, and you could have a hybrid app that has WebKit and some things are more native. But ultimately, if this were a great solution, we would be at a JavaScript conference. We wouldn't be Swift developers because there wouldn't really be a need for us to learn a completely new language and develop apps in Swift. We could just have one team of front-end developers that write JavaScript. Maybe that's the future, I don't know. Finally, architecture. Integrating React Native into an app is a huge undertaking. And not only the language, but just the fundamental concepts and how it impacts the architecture of the entire app. So, if you're trying to optimize an app for performance and it requires a lot of changes just to support Ethereum interactions, people might just decide not to do it. What we need is a Swift framework. A framework written in Swift, written by Swift developers, written by iOS engineers who know what our needs are, what kinds of products we want to make, and can optimize the experience of interacting with the blockchain for our needs. This is what it might look like. This is just a copy of the other slide. All the frameworks that are written in JavaScript, interacting with Ethereum accounts, interacting with contracts. And what we can actually do, because we're a little late to the scene, is build on top of the learnings of other languages and other platforms to make our framework even better. And we could actually add even more innovative modules, or JavaScript would be modules. We can add more innovative frameworks in Web3.Swift. For example, we could write Web3 UIKit, which makes it super easy to integrate well understood UI elements that tell users, oh, I'm interacting with the Ethereum blockchain right now, or this is a blockchain-based product. What could be even more interesting is supporting something like universal login. A ecosystem like Ethereum could make it possible to remove the need to integrate Facebook or Google login into mobile apps, into iOS apps. Instead, you could have a different login system that doesn't require you to give away your data, participate in those other platforms, where you own the data. And it's kind of an interesting reality to think about. It's very different from the way that apps look today. So I want to end on a question. How would you reinvent the App Store? That's a question. I'm sure that you have a lot of thoughts about the App Store, about iOS frameworks, about Cocoa. And what I want to tell you today is that you actually have an opportunity to make that level of impact in the blockchain development space. Because this framework, like I said, doesn't exist yet. And when it exists and when it's good, it's going to be integrated by so many products. And so any architectural observations you have around Apple frameworks, or observations about developer tooling, you can bring those observations and those learnings to this project. If it's a collective project pursued with the same community passion as something like AF networking or Alamo Fire or CocoaPods, we can create tooling and frameworks to best suit our community. Together, we can make it super easy to support blockchain integrations on iOS. The cryptocurrency future will be shaped by who's involved today. So, if you're passionate about corruption and supply chains and digital art collecting and gaming and governance, the government kind, not the cryptocurrency kind, the crypto world is for you. If you don't like how the crypto world is today, you can make it better. The crypto world is for you. If you want to support environmentally sustainable consensus mechanisms, the crypto world is for you, and that's one of the reasons why I'm involved. If you want to support inclusive finance, decentralized mapping, the crypto world is for you. there's space for you and whatever you care about. Together, we can transform the crypto world to be more social impact focused, more sustainable, and more optimized for Swift developers. Thank you.